Earth Science Faithful, check it. Geologic History. This is like Unit 6. First set of notes. We're going to start on page 3. Why is this statement false? The caveman had breakfast or had dinosaurs for breakfast. Well, that's impossible because they did not live during the same time periods. That's why. So you got to write that down. Then below that is the reference table we will be using the most. Looks like this. And I like this one because it's color coded better than the one in your packet. You can see it was color when it was printed. And you can see we're going to learn how to read this whole thing, this unit. Okay, more on that in a minute. So next page, page 4. An index fossil is something that is easily recognizable. You see, I got 4 bullets for you, and I'm very bright today. Abundant. There's got to be a lot of these fossils. We'll find there will be a large horizontal distribution if they live over a large geographic area. We'll see a small vertical distribution if they live for a short period of time. So those are things you're going to need to know when you're looking at the pictures of ways you can infer about these things. Okay. Fossils are found in rocks. Oh yeah, remember this? Our rock cycle. We're gonna learn a little, take this a little step farther because the fossils are found in these rocks, right? And they're found specifically in sedimentary rocks. Okay, I don't know if I left a spot for you to write that. Maybe that's the 4th bullet. But anyways, back to the picture. I see life on Earth, time periods, and the dates in there twice. So, sedimentary rocks are these guys here. There's their names. And metamorphic rocks, remember these guys? We're going to find the bulk of our fossils in sedimentary rocks. The heat and pressure that's going to make a metamorphic rock is going to hurt the picture that is the fossil. So matching index fossils and rock layers to determine relative age. That's what correlation is. In other words, our order of events. And this is the skills we're going to need to be able to do. It's not the actual age in years. It's just who came before who. That's why we call it relative. It's got to be compared to something else. That's what relative means. Okay, like here. And here. Right, so there's a correlation between this lower section of rock and this upper section of rock because we can match their fossils. Okay, see how we do that? And then same here, like 6 on one side is matched with 6 on the other side because of the fossil types, not necessarily the rock types. Okay. So we can match rock layers based on the fossils found in each rock layer. This is what correlation is. And the principle of superposition. Ready? The bottom layers are the oldest and the youngest layers are on top. That's just how the natural order of things works. So back to our diagram, this little snippet. The youngest is 0 millions of years ago, followed by 4,600 million years ago. So you see, newest is up top, oldest is at the bottom. So that will go here also. Youngest is on top, oldest is on the bottom. And notice that timeline runs through the middle of this picture too, which is on your reference table. It's on the far left side, but it's also again here. So if you're having trouble reading across, because it does that swoopy, so it's like a redone timeline based on that's going on. So using this principle, label the strata below oldest to youngest. Well, oldest has got to be A, and then goes to B, then to C, then to D. Right? Youngest has to be on top. And this is a cool picture showing what we're talking about. You see the stripes going down. You see the banding. You see it broke. You can start to match things up, which is neat. The principle of cross-cutting relationships. So this is going to be the other piece that we're going to use when we're looking at these pictures. Intrusions, faults, joints, and veins are all younger than the rock layers they cut across because the rock layers had to have been there before those things happen. Okay. Faults are always older or younger than? Well, they are younger. And it says, which is older, F or S? Well, uh, S has got to be older because F is the fault, which had to have happened before. So the older's got to be S. And then the fault happened, and then a new layer was put on top after that. F cuts through S, therefore S must have been there first. It's older. Make sense? This might be it for today. Oh, we might as well do unconformity. It's on this page, and we'll call it a video, and we'll do the next page. So, unconformity is a buried erosional surface. Layers of rock will be missing because they've been eroded away. This is caused by weathering and erosion, which was our last unit. Okay? It's going to look like this. So that where there's that hill, that is some unconformity. Notice it's not layered. Nice. And that is going to generally have a letter code on either side, like an A and an A prime or a B to a B prime. You'll see a lot of that. You have to be able to tell me what was going first. Okay. But using the diagram to the left, identify where the unconformity is by drawing an arrow and writing the word unconformity next to it. Oh, I don't have you. I just want you to be able to understand what this picture is and how to do it. So when you see it in a castle or something, you can do it. Okay. So unconformity. There's a perfect unconformity. And it also looks like possibly an intrusion. We're going to get to that next, which is next. We'll save that for next video, next page. All right.